Greetings everyone. Welcome to A&E Learning Hub, where I'm going to go through and explain the solutions for questions related to primary and secondary cells. All right, so for the first question, question 7 from the 2008 past paper question. So let's begin. Part A, it says, state the difference between primary and secondary cells. Primary cells are cells that cannot be recharged after being used, while secondary cells can be recharged by using a DC source after being used. All right, so that's it for part A. For part B, it says, state 2 precautions which should be observed when charging secondary cells. The first precaution is that the charging rate by manufacturer should be observed. The second, correct polarity must be observed when connecting cells to a charging device. All right, so that's it for part B. For part C, 1 of C, it says, explain briefly the principle of operation of a lead acid cell. Lead acid cell consists of 2 sets of plates immersed in an electrolyte of diluted sulfuric acid. The plates are constructed in the form of lead grids, which serve as a frame to support the active paste, a mixture of lead oxides and sulfuric acid. During charging, the active material is converted to lead dioxide on the positive electrode and to spongy lead on the negative electrode. All right, so that's it for part 1 of C. Part 2 of C, it says, state 2 main indications of a fully charged lead acid cell. 1, ion constant specific gravity. 2, charging voltage is steady. All right, so that's it for part C. Part D now, it says a 6 ohm resistor is connected across a lead acid cell. The potential difference across the battery terminals is 20 volt for open circuit and 18 volt when the circuit is closed. Calculate the current in the circuit. In order to calculate the current, we'd have to use the closed circuit voltage, because the only time current can flow is when a load is connected to the circuit. So it means that current is equal to voltage divided by the resistance, that is 18 volts divided by 6 ohm will give us 3 ampere. All right, so that's it for part 1 of D. For part 2, it says to calculate the internal resistance of the battery. So R is equal to the open circuit voltage, V, minus the closed circuit voltage, E, divided by the current. So that is 20 volt minus 18 volt divided by 3. That will equal to 0.67 ohm. All right, so that's it for part 2 of D. And that's it for this question. All right, so let's move on to the next question. And this is question 8 from the 2009 past paper question. So part A, it says, explain briefly the difference between primary and secondary cell. Primary cells are cells that cannot be recharged after being used, while secondary cells can be recharged by using a DC source after being used. All right, so that's it for part A. For part B, it says, state the expression for internal resistance R of a cell in terms of its EMF, E, and the terminal voltage V for a load current I. All right, so this is the expression here. R is equal to E minus V divided by I. All right, so that's it for part B. All right, so for part C, it says, for a primary cell, explain briefly the terms polarization. That's for part 1 of C. Part 2 of C, local action. So for polarization, If a cell is left connected for some time, the current decreases rapidly due to high resistance that is caused by the accumulation of hydrogen gas around the positive electrode. 2, local action. So this is when the electrolytes attack the impurities in the zinc, forming small cells and corroding the electrode. All right, so that's it for part C. For part D now, it says state 2 advantages of an alkaline cell over lead acid cell. 1, long battery life. 2, high energy density. All right, so that's it for part D. Let's move on to part E. It says the voltage at the terminal of a battery is 12 volts when no load is connected, and 10 volts when a load causing a current flow of 8 amp is connected. Part 1 of E, it says find the internal resistance of the battery. R is equal to E minus V divided by I. That is equal to 12 volt minus 10 volt divided by 8 amp. That will give us 0.25 ohm. So that's it for part 1 of E. For part 2 of E, it says, what would be the terminal voltage when a load causing a current flow of 5 amp is connected to the battery? So V is equal to E minus I times R. So therefore, V is equal to 12 volt minus, in bracket, 5 amp times 0.25. That will give us 12 minus 1.25 equal 10.75 volts. All right, so that's it for part E, and that's it for this question. So let's move on to the next question now. So this question is question 4 from the 2010 past paper. Part A, it says state the difference between primary and secondary cells. So primary cells are cells that cannot be recharged after being used, while secondary cells can be recharged by using a DC source after being used. Part B, it says list 2 methods used to determine the discharge status of a lead acid battery. 1, so the first method is to use a voltmeter to test the voltage level of the battery. 2, the second method is to use a hydrometer to test the specific gravity of the battery. So those are the 2 methods. All right, so that's it for part B. For part C, it says give 1 advantage and 1 disadvantage of the lead acid cell over the alkaline cell. 1 advantage, it withstands slow, fast, and overcharging. 2, disadvantage, it has low specific energy. All right, so that's it for this question. Let's move on to the next question, and this is question 2 from the 2013 past paper question. Part A, it says list 4 methods that can be used to charge secondary batteries. 1, trickle charge. 2, constant current. 3, constant voltage. 4, floating system. All right, so that's it for part A. Part B, it says figure 2 shows 4 lead acid cells connected in parallel. Each cell has an EMF of 2 volts and an internal resistance of 0.8 ohm. The battery supplies a load of 0.8 ohm. All right, so here is figure 2, the lead acid cell. So let's look at what it asks us to calculate. So it says calculate part 1 of B, the total internal resistance of the cell. So the formula, R is equal to 1 divided by N times R. So N is the number of resistors in parallel, and R is the value of 1 resistor. All right. So R is equal to 1 divided by 4 multiplied by 0.8 ohm, and that will give us 0.2 ohm. So that's the total internal resistance. So that's it for part 1 of B. For part 2, it says calculate the total circuit resistance. So RT is equal to R plus RL. That is 0.2 ohm plus 0.8 ohm. That will give us 1 ohm. For part 3, it says to calculate the total circuit current, IL. So I is equal to V divided by R. So that is 2 volts divided by 1 ohm, and that will give us 2 amp. So that's the total circuit current. All right, so let's move on to part 4. It says to calculate the terminal voltage of the battery. So V is equal to E minus I times R. So that is V equal to 2 volts minus, in bracket, 2 amp multiplied by 0.2 ohm. That will give us 1.6 volts. All right, so that's it for this question. All right, so let's move on to the next question. So that is question 2 from the 2014 past paper question, part 1 of A. It says, name 2 instruments used to determine the level of charge of a secondary cell. So the 2 instruments are 1, battery tester, 2, voltmeter. Part 2 of A, it says, name 2 types of primary cells used in products such as computers, watches, and cameras. So the 2 types of primary cells are mercury cell and alkaline cell. All right, so that's it for part A. For part B, it says calculate the internal resistance of a primary cell with an open circuit terminal voltage of 1.5 volt and a closed circuit terminal voltage of 1 volt when the cell supplies a current of 0.5 amp to an external circuit. So R is equal to E minus V divided by I. So that is 1.5 volt minus 1 volt divided by 0.5 amp. That will give us 1 ohm. All right, so that's it for this question. All right, let's move on to the next question. And this is question 2 from the 2015 past paper question. For part A, it says figure 3 shows the drawing of a dry type lead launcher cell. So it says in your answer booklet, write the letters A, B, C, and D. Name the parts of the cell identified by each letter. All right, so for A, that's the rod. For B, that's the mixture of poured carbon and manganese. For C, that's the sal ammonia paste. And for D, that's the outer cover. All right, so that's it for part A. For part B, it says briefly describe each of the following as it relates to the conditions in a lead launcher cell. So polarization. Part 1 of B. If a lead launcher cell is left connected for some time, the current will decrease rapidly due to high resistance that is caused by the accumulation of hydrogen gas around the positive electrode. Part 2, local action. This is when the electrolytes attack the impurities in the lead launcher cell, forming small cells and corroding the electrodes. All right, so that's it for part B, and that's it for this question. And that's it for all the questions related to primary and secondary cells.